This is Wind Hero from speedsolving.com, and today I'll be showing you how to do basic edge pairing with the 5x5. Free slicing is a method that allows you to slice the cube through the whole solve until the very end of the solve. If you do regular edge pairing, one pair at a time, you have to restore the centers after each pair. With free slicing, that is no longer needed. The idea is that when you do slice the center, you cannot do 180-degree turns on the front side, on the right side, or on the left side. Pretty much everything else is allowed. Doing 90-degree turns is allowed, but you have to restore it after you do it. Basically, if you have an algorithm that has a right clockwise turn, it has to have a right anti-clockwise turn, so that these middle lines remain unharmed. You begin by looking for 3 pieces that make an edge pair, and then you line all of them and hide them up in the top layer. When the top layer consists only of corners and completed edge pairs, you turn the cube around and repeat. In the end, you will have 8 solved pairs on the top and bottom layers and 4 unsolved pairs in the middle layer. All of the algorithms used during this tutorial are in the description. The names for the algorithms I'll be using are the following: the hiding algorithm, the swapping algorithm, the front placing algorithm, and the top placing algorithm. The idea of the hiding algorithm is that you take an edge pair and replace it with one edge pair that is on the top layer. So basically that's the hiding algorithm. The swapping algorithm, you turn one edge pair upside down. So here in this case you would have this piece here, and this piece remains here, but swapped around. As you can see now, orange is on front and now it's green. All of these algorithms move the edge pieces without harming the center lines that are formed when slicing. If you stick to these rules, you will be able to free slice and cut down your move count during edge pairing phase by quite a bit. A good method for fast edge pairing on big order cubes such as the 5x5 is to use color filtering. This means that you would pair the colors you are best at recognizing first. I saw a white cross, so I'd look for the edge pieces with white on them first. After those are solved, I would move on to yellow pieces. When those are done, I do the remaining 4 edges that have green, blue, red and orange on them. I begin edge pairing by facing the white center on top, starting to look for white something edge pieces. The pieces have to be brought to the middle layer, sliced to match a complete pair and hidden to the top layer which has the white center. So how I'd start is, now I noticed a green-white piece right here, and it's another green-white edge piece is right here, and these are both like external edge pieces. So if one is here, the other has to be here, and then the middle goes here. So it's right here, so I want it here because this one is already on the bottom line. I want this to go there. So I use the top placing algorithm, and then I slice, and they're together. Now I go ahead and look for the green and white center edge piece. Here's the blue and white, I need the green one. It's not on the top layer, it's not in the middle layers, so I'll have to go look from the bottom layer. And there it is, right here. Green and green, because I want the white to be here, I use the front placing algorithm. If I wanted green, which is on top, I'd use the top placing algorithm. So front placing algorithm, and there it is. And now I turn the cube back so that the white is facing top. Slice, slice, and there we go. Here's the first formed pair, and we don't care about these lines at all, or the center lines for now. So now we hide it on the top layer with the hiding algorithm. Next phase, here's orange and white. Orange and white. Here's white on front, I want the orange right here, so that when I line them up, they can be sliced together. So top placing algorithm on the left, slice together, go looking for the last orange and white piece, which is on the bottom layer, and right here. So it has to go on top. I want this orange right here. So what I would do is I would have to do it from this side. Everything is unharmed. Put the orange in place, turn the cube around again, and now use the hiding algorithm. The hiding algorithm is used best when you have a completed pair right here on the top layer. You put it on the side, so in this case I've got the completed pair here on the right column, and another completed pair. I have to have it on the same column on the same side. Not like this, not like this, not like this, like this. Hiding algorithm, and there we go. Swap with a broken piece. Then we have red and white oriented the wrong way. One of them is oriented the wrong way. Look from the bottom layer, here's one. I want the white to be here, because if I have white here and slice it, it's gonna turn red. This is wrong, so I'm gonna front place it, left bottom, slice it, and now I want to turn these around so that when I slice back, this will fill this gap. So swapping algorithm and slice back, and there it is. Hiding algorithm, same idea. Have something solved on this side, so not like this and not like this, and this is fine. So when I hide it, I have to swap it with this broken edge or this broken edge, but not with a solved one. And then we have the last one, which is blue and white. Here's one. White right here. Slice together. And then the last piece, which is here. Top placing algorithm. Slice together. Completed. And now I can show you on the left side the hiding algorithm. So and now the white face has only corners or solved edge pairs. Now we turn the cube around, and now we go looking for pieces that have edge pieces that have yellow on them. So first I'd see orange, yellow, orange, orange, yellow. Line them up, go looking for the last piece, which I actually saw, it's right here. So this is on the top layer. So if I were to turn these around, this pair, and slice 2 times, I'd get the last piece that is also on the top line. to match up. So turn these around, and there we go. Hide it on the top layer, blue, yellow, line up, top placing algorithm, line up, hide, red, yellow, this has to go on top, so front placing algorithm, line up, and here's actually the red, yellow centerpiece right here, so line that up, hide it on the top layer, slice green, yellow, slice those together, green, yellow center edge piece, for top placing algorithm, because we want yellow here, green, we want yellow here, and hide it on the top layer. And now we're in the situation where we have 4 completed edge pairs on the bottom layer, the white face, 4 completed yellow edge pairs on the yellow face, and the last 4 layers and the middle slices are wrong. So now this is where free slicing is the best. Now we just slice everything back, and what we have is we have 4 pairs that are broken, but we have all the centers intact. So now I notice I have blue and red. So, and here's a blue and red, so I turn this around but with the swapping algorithm, like so. But if I want to, now we would have to edge pair like the very basic method, so I need some pairs to restore this with, some broken pairs. So if I do this and try to swap it with something, it's gonna break another edge. So we need a broken edge on the top layer, like here. So line that up, swap it with this pair, and line it back, and then I actually fixed this at the same time. And here's the last one. Green, orange, orange, green. So let's try one piece at a time. What happens? Match those two, swap this around. Okay, looks good. And now here's a case where you can do it just once. So with one algorithm, if you get this case, you just slice like so, so that the blue and oranges line up. Then swap the blue and oranges upside down, just like we did with the green and orange a second ago. And slice back, and there you go. You have a solved cube. Now you would go into F2L. What can happen is that you end up with a parity. Parity looks something like this. So everything else in the cube is solved except for one edge pair, which is oriented the wrong way, like so. So two facing one way and the center facing the other way. The fix for the parity algorithm is an algorithm that is 17 moves long, but it can be done in under 2 seconds if you're really good at it. So I'll put the algorithm in the description and show you slowly how to do it right now. And there you go, it's solid. And everything in the bottom layer is unharmed. And I guess that's it. If you have any questions, please comment or contact me via private message on speedsolving.com forums. Thanks for watching. Bye.